Our next talk is going to be Saurabh Wadhwa with Resource Smart Detection with YARA and OSQuery. So his talk is going to be obviously on YARA and OSQuery, which I think we all could know a little bit more about and figure out the different use cases. So if you're there, Saurabh, I'll go ahead and turn it over to you, and we'll kick this back off.
Hi, everyone. Happy Friday. My name is Saurabh Wadhwa. I am a Senior Solutions Engineer with Optics, and I would be covering the topic YARA and OSQuery and how they can work in conjunction to overcome some of the limitations that YARA has when it comes to resource utilization. To start off things, okay, so what is YARA? Right, YARA actually stands for yet another recursive or yet another ridiculous acronym. I know it's a funny thing, but YARA is used by malware researchers or threat researchers to identify a malware or a family of malware by looking for certain conditions, right? So in the next slide, here you see an example of a simple YARA rule, right? This is pretty simple, pretty basic, but you can always construct complex ones. And the syntax of the YARA rule follows the C programming language syntax. So you have an identifier, you have the word rule and then an identifier. In this case, we are looking at three strings, $A, $B, $C. Two strings are hexadecimal notation. One is plain text. And if any one of these three strings is present in the file, then it's a malware. So it's a match, right? And on the left-hand side, you can see the different type of strings we can search for. Hexadecimal strings, as you can see in the image, text strings, regular expressions, which makes it more powerful if you want to do pattern matching, or private strings. So typically what happens is once YARA returns the results, it displays the string. So if you don't want the string to be displayed as a part of the output, you can mention it as a private string. In the images shown here, if you take a look at the image on the left-hand side, under the conditions section, so we have two strings, $A, $B. The condition is if there are exactly 6 instances of A and more than 10 instances of B, then it's a match. So I'm just trying to portray more options that we can have when it comes to conditions, right? And on the right-hand side, under the condition section, you will see $A at entry point. So basically what it means is it will store the virtual address, the entry point virtual address of the executable. So that's what it means. Here are some more options when it comes to the conditions section of the YARA rule file. So you can have, you can count the occurrences of a string. You can match on length, file size. If you know that a malware has a file size of 200 KB, you can, specify like a condition which is file size greater than 200 KB and so on. So these are some of the conditions that you have when, when it comes to matching against the YARA rules. Now I will take an example of a real life malware. It's called Connie Rat, and it was supposedly linked to a bad actor group called APT-37 based out of North Korea. And what happened was, how the attack was launched, the actor utilized a malicious MS Word document, right? And that document contained 3 hidden text boxes. And there was a hexadecimal string embedded in those text boxes, but in reality, it was a series of commands, right? So what happened was once the victim downloaded the document, opened it up, the commands got executed, and one of those commands was actually going to a command and control server and downloading a payload. So in this screen, you see the different text boxes, and if you pay attention on the right-hand side in text box 3, so I'll just give you a gist of what this command does. So we have this utility called certutil.exe, which is used to obtain certificate authority information, and it can be used to configure certificate services. But the attacker can use it to download a file from a remote server. And this is what happened in this case. The attacker renamed the certutil.exe to mx.exe so that it evades detection. Then it downloaded a file called 1.txt from a remote server. It renamed the file from 1.txt to 1.bat, which was actually an executable file. And once the bat file was run, then came the further steps in this attack, which were like privilege escalation and lateral movement and data exfil. Now we will see a couple of slides which define the YARA rules that were used to look for Connie. So Connie had like two parts. One was the layer document and the payload, right? In this coming screen, you will see the YARA rule for the layer document. It's nothing but it's basically looking for, there are 8 strings that are defined, right? S1 to S6 and A1 and A2. So condition is if any 4 of the S strings from 1 to 6 and one of the strings from A is present, or there are 5 strings from the S strings, 1 to 6. So if any one of these condition matches, then we know that it is actually a malware. And in this scenario, this is for the payload, the Connie payload. I will go through certain identifiers, so that it's more clear what exactly we are looking for. So typically, if you're looking for a string, right, even without the ASCII keyword, it will go for the ASCII encoding. It will look for the ASCII encoded strings. You can specify ASCII, even if you don't, it's the same thing. Then we have another identifier called wide. So what happens is, in a string, if the characters are encoded using 2 bytes, then we have to use the wide identifier. And what full word means is, basically, if you are looking for a text like ABC, inside the file, you have a string like my ABC, so there won't be a match. If there is ABC, then it would be a match. And if there is something like my dash ABC, then again there would be a match. So basically it means like full word will catch on words that do not have prepend and append the word with the character. So that's what it means basically. So here are some additional YARA resources. It's a really powerful tool when it comes to malware analysis. And you can go to these resources. You can actually download the YARA rules for real life malwares that were discovered, and someone wrote the YARA rule signature file for detecting these malwares. So you can go to these resources, take a look and read up more about what YARA is. What I showed were like simple conditions, right? But they're like thousands of possibilities how you can build a YARA rule file. You can add as many rules as you want in a particular file. For example, like 100, 122 rules, and it will check the files, the source files against all those rules. Now let's focus on the analysis of YARA, like the performance. So scan time increases with the number of files. On the left-hand side, the table, it shows the directory, the number of files, and the number of seconds it took to run the complete scan. In etc directory, they were like close to 2,400 files. It took half a second, not bad, pretty good. But when we went to the user directory, it had close to 604,000 files. And the time taken was a little over 2 minutes, but the collective time was 2.5 minutes. In computing world, it's still a lot of time. And we ran the scan just with 9 rules. Imagine running a scan on 655 files just with 9 rules, and it took more than 2.5 minutes. Next comes, the scan time increases with the number of rules itself. Right? We just had 9 rules, so it was pretty easy to run the scan. But if you see, one rule runs in 20 seconds. If we, the count of the files here is close to 130,000. So, still a decent amount of files. And if you see, if the number of rules increase to 122, again, the scanning time is 258 seconds. So these are like, like a few limitations of YARA when it comes to like this resource utilization, like how much time it spends running the scan. And it was tested on like an i7 machine with 1.8 gigs of processor. The really cool thing about YARA is that it actually provides performance warnings for the rules. So if we have included a regular expression and we did like match like dot star, it will actually tell us that this is not optimum, and it will tell us that we need to change it, right? But still, even when we tune the rules, how much computing resources does YARA consume? That's the main question, right? You don't want your endpoints, your servers to be overburdened just with YARA, right? There are like other processes running, other applications running. YARA should be a small piece of the chunk. So in our case, right, when we ran a standalone YARA application, we scanned the files, 122,000 files, the CPU utilization was pretty high. And as you can see the highlighted box, it was close to 197%. And it basically consumed all the CPU resources, which is not an ideal scenario. Now the question is, with all the limitations on resource utilization that YARA has, is it still helpful? Does it still make sense to use it doing malware research? The answer is yes. And how can we do that? Here we introduce another thing called OSQuery, right? So how OSQuery helps complement YARA is OSQuery can provide every process that's running on a machine. And the second piece is it will monitor your sensitive files and folders for any changes. Hence, we can target the YARA scans to only the processes that are running and the files that have been modified, added, like if for example, renamed. So we can run a targeted YARA scan on those particular processes and file events. And the cool thing is we can run YARA directly from OSQuery. We don't need a separate instance of YARA when it comes to like working with OSQuery. So what is OSQuery, right? This is a question I also had before I started learning about OSQuery. So OSQuery is a framework which transforms the underlying operating system into a relational database. For example, like I have a Linux machine, CentOS or Ubuntu or Windows. I can query my operating system, my machine, just like I would query a relational database. For example, select star from processes, a simple query. It will return back the results. It will show me all the processes currently running on the host OS. In the figure, in the image shown, it's basically selecting name, path, and process ID from processes, the table, where on disk condition equal to 0. So you can query your system like a database, which is another cool thing in itself. And to tell you about like a little history about OSQuery, it was actually started by Facebook. And now it's open source. It's controlled by the Linux Foundation. There are 3 features. It's fast and tested. That's why all the big organizations like Facebook, Uber, Google use OSQuery. It runs everywhere. It means it has the support. It supports the different major operating systems out there, whether it's Windows, Mac, CentOS, like then Red Hat, Ubuntu, and it's open source. Again, it's open source, so you can go in, you can download it from the OSQuery website, you can install it, you can test it out, you can make changes. So it's that's Another cool feature that, cool thing that it has, it's basically open source. Here is a screenshot of the schema for OSQuery. It's like, all tables, they're all virtual tables. So we have close to 263 tables in OSQuery. And on the right-hand side, it shows the major operating systems it supports. OSQuery eventing framework. I will explain this piece in simpler words. So OSQuery is all about querying your system. Select stuff from processes, select stuff from process events, select stuff from file events, and so on. There may be a case where a malware gets installed, the process starts and finishes in a fraction of a second or a couple of seconds. And by the time we send the query the next time, like select stuff from processes, we would miss that event. And that's pretty critical because a malware started and ended a process and we don't even catch it, right? That's not a good thing for sure. To solve this problem, OSQuery exposes a pub/sub framework. So what it does is it aggregates the operating system information asynchronously at event time. So once the event happens, it gets stored in the OSQuery backing store. And the table it gets stored into is process events table, right? As soon as a process happens, it gets recorded into the process events table, and we can run a YARA scan only on those processes, right? There is no need to run YARA scan on any processes which are which have been there for a long time. As soon as a process happens, we can run a YARA targeted scan on the process events table. Then the second piece is the file integrity monitoring. So you have sensitive data lying in your files, folders, and you want to monitor those files and folders for any changes. OSQuery has this functionality called FIM, or file integrity monitoring. What it does is it can monitor the specified files or directory for changes. And it utilizes iNotify and FS events frameworks in case of Linux and Mac OS. And what happens is if any of the files changes, if the file gets renamed, in case, if a malware is doing that, or it writes data to a file, it adds a new file, the YARA scan can actually run on those file events. And if there is a match, it can let you know that, hey, there was this condition which actually mapped to a malware. I saw a file getting added and the condition matched, hence your machine is infected, like something like that. So it's basically, YARA looks for conditions inside a file or a process. And if there is a match, it lets you know. Downloading and installing OSQuery is pretty easy and straightforward. So it's available on the website osquery.io. And here we ran an RPM file for CentOS, but there are other packages available according to your machines. You have like for Mac OS, Windows, Ubuntu, there are packages available for you to download and install on the OSQuery website. And again, if you note, you don't need to separately install YARA in order to run YARA through OSQuery. Again, saving system resources because they're working in conjunction. So configuring targeted YARA scan of every process execution using OSQuery. So OSQuery, how it runs or what it does is controlled by a flags file, right? And to enable the event framework, the pub/sub framework we just talked about, we need to add a few flags inside the flags file, which is located in etc OSQuery, and then the name of the file is osquery.flags. So there are a few options, like disable events equal to false. It means it will capture the events. Disable audit equal to false. It means enable auditing, and audit allow config equal to true. So once we add the flags in the flags file, we will start capturing the event data. Here is an example of how an OSQuery conf file looks like. So in the OSQuery conf file, we must define one or more set of YARA rules, right? So in this case, if you focus on the image, right, we have a YARA signature group called sig group 1, which contains of one sig file, rules 60. But you can have multiple sig files within one group, right? In this case, we took one, rule60.sig, and then we have specified, file paths, like, home, like we have specified that anything under the home directory will be scanned using sig group 1, which consists of the rule60.sig file, right? So it's basically a hierarchy how the scanning works. And if we want to run a YARA scan for every process from the command line, right? So we can use this option where we use the interactive command line interface for OSQuery, which is OSQuery I. So we can use the command sudo OSQuery I and specify the config file, which is the .conf file, and the flag file, which is the OSQuery.flags file. In this image, it would be more clear how things work. So in case of FIM, file integrity monitoring, right, we have specified three folders we want to monitor. One is homes, which consists of home. Percentage means any user, then private if any of the users has a directory private, and percentage means all the recursively occurring directories and subdirectories. So we would be monitoring home, user, private, and all the subdirectories. Then we have the second option, which is SSH keys, which is looking for root.ssh / all the subdirectories, and home, the user.ssh folder and the subdirectories. And then we have the third folder as etc. But in this case, we have applied sig group 1, which consists of one signature file, and it's running a scan on homes and etc, right? So we left out SSH keys, but we are running targeted YARA scan for file integrity monitoring if something changes in home swadha private directory, or something changes in etc directory. Someone went in, deleted something or made a change in one of the files inside the etc directory, then the YARA scan will run, and if there is a match, it means a malware is installed and it's doing something malicious. So again, to reiterate what I said, with FIM enabled, once an update is made to a monitored file or a folder, each change will trigger a YARA scan, and if there is a match, the results would be stored in the YARA_events table, right? So in the image below, you can see what was the target path and what was the match. So it was a file event which actually got matched with the YARA scan. And now when we see the resource utilization for OSQuery running along with YARA, the utilization is down from 197% or 193% to just 5%. The reason is because we have made the YARA scans targeted, right? We are targeting only the processes. We are running scans on the processes as soon as they happen. And in case of the file integrity monitoring piece, we are just monitoring and running scans in case of a change. It's not like the files are just lying there and we are running scan again and again. No, if there is a change within those files, only then we'll initiate a YARA scan. So concluding my presentation, here are a few pointers. YARA is a powerful pattern matching Swiss Army knife for identifying and classifying malware files. It can detect a particular strain of malware or a family of malware. Wholesale system scans can become expensive quickly, as we saw that running a YARA scan again and again took up a lot of system resources, and we certainly don't need that. Then targeting a smaller set of files, such as those like the processes that are running, and high-risk directories in case of file integrity monitoring, it's really important for saving on computing resources. And OSQuery can identify both running processes and monitoring files. And as I already said, that once a process starts, it gets entered into the process underscore events table. We can launch a YARA scan. And similarly, if in case of FIM, file integrity monitoring, if there is a change to the critical files, then YARA scan can be run only on those particular files. So thank you for listening to the talk. And if you have any questions, there is my email address on the bottom right-hand side. Please feel free to ask any questions during the on my channel, or if you want, you can email me on my email also, and I would be more than happy to answer.